Good morning, good morning. All right, welcome back. We start on page 19. And while we're opening to page 19, we'll take our quick look at the calendar. Okay, so I've highlighted a few cells in the calendar. First row that's highlighted, that's today. It's class number 4. And the section we talk about is the derivative at a point. That word derivative is a word that we're going to be using almost every day for the rest of the semester. Today's our first intro to it. In the next row, that highlighted cell, number 1, what does that represent? The first number 1 is a quiz, and it is on classes 1 through 4. That is everything we did from the start of this class and through today. So just a note on our quizzes. Some of this is written in the syllabus, but I just wanted to highlight it here since we have a quiz coming up. First of all, many of our quizzes will be no calculator. So I'm not going to ask you to do crazy arithmetic stuff like we've been using the calculator to do some problems. But I could give you like a screenshot of the calculator and say, you know, what can you say about the limit based on this data? So still, I'd like you to be able to use a table or a graph to estimate a limit, even if you don't have that tool in your hand. Also, you will be able to use an index card, which you can write on that anything that you want to. So if there are formulas or hints or theorems or vocabulary or sample problems that you'd like to be able to refer to, just make an index card between now and next class, and then you'll use that index card on the quiz. Bubba? I don't know how many questions, but I'll tell you that it's on one page front and back, every quiz for the semester. So, you know, I mean, it could be like 4 questions or maybe 2 longer questions. It depends. The amount of time that the quiz will take is also going to change based on the quiz. I will tell you that the quiz coming up is 18 minutes. I have a way that I calculate how long I think the quiz should take. So that's not a random number that I'm throwing out there. So 18 minutes is our quiz, which means it's going to go from 8:40 until 8:58. So this coming Friday is a bad day to show up 10 minutes late for class because the quiz ends at 8:48. That said, if you tend to take a little bit longer on tests and quizzes, you are welcome to start this quiz 10 minutes early. And we'll still go until 8:48, regardless of when you start. So show up by 8:30 if you want that extra time, and that 8:30 will be standard for all of our quizzes during the semester, okay? All right, so I think that's that. And the next thing is back here. So on the bottom of page, or I guess in the middle of page 19, we'll start with number 1. And can we go with Andrew? Okay, so let's start there. So we know average velocity. We've done it a whole bunch of times, but we'll write it here. The average is equal to, I guess it's just change in distance over change in time. And so if we wanted to write that more using the notation that we've been using this semester, it's been something like, let's see, so something like this. S of A plus H minus S of A all over H. And I wanted to use the H version in this problem because the H version is the one that we're going to be using most of the next week or so. So let's make sure we're clear on what this represents, why it's a reasonable thing to talk about for average velocity. First of all, that change, where do you see the change in the top of this fraction? What symbol in the top represents change? H. Not H. Well, kind of H, but it's the subtraction, right? You are subtracting 2 distances. That's how you are finding the change in distance. So the 2 distances, let's see, I guess we're looking at A is 1 moment in time, and then A plus H is jogged off a little bit from that 1 moment in time. How much time has passed between A and A plus H? H, right? H seconds has passed. So that change in time downstairs makes sense as just H. So this is our H version of things. It's a little bit different from the other version of things, but that's the one we're going to be focusing on. Garrett?
Were you saying the other day that if you do it right, the H in the bottom should always cancel out?
Yes.
Okay. I was trying to do it on something, I don't know if it's in the home work, or the H didn't cancel out, so I'm guessing I made like a mistake.
Generally, that means there's an error somewhere. If you show it to me after class, I can take a look at it. We're actually going to do it in part C of this one for this example anyway. Yeah, that H needs to go away. Okay, so let's see if we can find it for part A. So we need to do S of 1.1 minus S of 1 divided by, let's see, how much is the change in time for this example? 0.1? Do you guys see the purple and the red as being the same thing? How much is the H? Is the 0.1? How much is the A? Is the 1. So, okay, 1.1 is 1 plus 0.1. I don't have to write it that way, but that's what it is. So they say the same thing. So with the calculator, we're just doing 1.1 squared plus 2, and then we're subtracting 1 squared plus 2. So let's try this on the calculator. Once you've got that, see if you can do B. Okay, any questions on either of those calculations? In theory, we probably should be checking, you know, maybe 0.9 up to 1 and 0.99 up to 1. We want to go on both sides, but do we have a guess as to what the instantaneous velocity is at t equals 1 second? Feels like it's kind of honing in on 2. Great. So, you know, numerically, evidence suggests that the velocity is 2, but, you know, it's not a proof. It really could be 2.00043 and never gets to 2. It gets to that crazy other number. So, so here's where we do the algebraic way, the full-on hardcore algebra to really find out that the velocity is 2. So how do we do it? All right, so we did something like this last time. We're going to write down basically that definition up there in purple, but how much is A? A is 1 in this problem. A is the moment in time that you're focusing on. So let's do S of 1 plus H minus S of 1 divided by H. And we actually gave a name to this fraction the other day. Anybody remember it? It's 2 words. It's the difference quotient. Difference because there's subtraction, quotient because there's division. Okay, the easy part is here at the end, S of 1. How much is S of 1? It's 3, still 3. The part that a lot of folks end up getting wrong is this other part, S of 1 plus H. Here is what I really don't want you to do. I don't want you to say, oh, okay, it's just S of 1, which was 3, and then plus H. That is not right. You can't just find S of 1 and then stick on an H at the end. What we need to do is really plug in 1 plus H to our function. So let's try that here. So this 1 plus H is going in for that T, and if there were other T's up there, it would go in for all the T's. So this thing becomes, let's see, it was T squared, so what should it be down here? Should be 1 plus H squared. And what else was there in the function? Was a plus 2. There's also a plus 2 here. So this whole thing is S of 1 plus H. I think that's the hardest part of this problem. Any questions on what we did? Okay, and so now we've got to do some algebra. So let's do some algebra. What might we do first? Yeah, maybe we'll FOIL that 1 plus H squared. And the plus 2 and the minus 3, they do combine, but I'm just going to copy them both here for a second, just because I want to point out something that's going to happen. So Garrett had asked a question earlier today. He said, so does the H really need to cancel in the bottom every time? And the answer is yes. So if the H is really going to cancel, then all the terms without H have to go away, right? The only way that H is going to cancel is if we can factor an H out of everything upstairs, which means whatever doesn't have an H had better go away by itself. So we can factor that H out. And And it works. It works as if by magic every time. 1 plus 2 is 3, minus 3. Every term has h. Now that we see h's in every term, we factor it out. What's left? Okay, I'll write 2 plus h, but h plus 2 is good. And then what happens? H is canceled. And so when all is said and done, this difference quotient boils down to 2 plus h. And one last little thing to do. It's really easy. But are there any questions on this so far? Yeah, Todd. That's right. Yeah, it's always a number plus h because it's always this purple thing up here. Whatever number you want, plus h. Okay. All right, so the last thing we had to do was send h someplace. So remember, if you're sitting here at t equals 1, then 1 plus h is maybe off here to the right somewhere. What do we want to do with these 2 points in order to get the instantaneous velocity? Yeah, we want to squish them together. You want this h thing to land almost right on top of the other point. So what are we sending h to if h is how far apart they are? We need to send h to 0. So I'll write that last. The instantaneous velocity is the limit as h goes to 0 of that thing, 2 plus h. And the first time you see a limit, you just try plugging in. What do we get when we send h to 0? 2. And 2 was the guess that we had made for the instantaneous velocity. Questions on that? Okay. Abby. H going to 0 is actually part of that definition. H is independent of the t equals 1 that we were focusing on. So h going to 0 is our way of smushing the kind of random point onto the one that we care about. So h is always going to go to 0. Yeah. Okay, next page. Number 2, I think we're up to Joe.
For a general function, average velocity change in instantaneous velocity instantaneous rate.
Okay, we'll go to 3. You are Andy. No, you are Chris. Okay, the only difference between that thing and the formula we just wrote on the previous page is what letter? Is the F. That's it. We called it S for the last few classes because we've been focusing on S as a height function or a distance function. But now we're just making F any old function. But it's the same idea, same exact formula. And Abby's question is answered here. H is going to 0. It's part of the formula. What's the only part that might change? Is the A. That's the moment in time that you're thinking about. So A could be any number, as Todd says, but the H is always going to 0. Okay, let's try number 4, Nikki.
The population PFT China variance is classified by PFT equals 1.7 times 1.007, where T is the number of years since the start of 2000. Use this model to estimate how fast the population was growing at the start of 2000 and at the start of 2007. Rounding to 7 is a bad idea. Do your answers in millions.
Okay, so let's try this one. We've got a function, p of t. It is not a height function or a distance function. It is a population function. If I were to plug in t equals 5, just to make up a number, what would that represent? It's 5 years after 2000, so 2005. And what is this formula going to give you in 2005? China's population at the start of 2005. If I plugged in 5.5, It would give me China's population in the middle of 2005, okay? So you plug in any numbers you want to into that formula, and it tells you China's population at that moment in time. So what if we tried this idea of average velocity? Okay, it doesn't make sense to talk about the velocity of China's population, but it does make sense to talk about the rate of change of China's population. China's population is presumably growing, but do you think it's growing linearly? Like every year it's the same increase in China's population? No, probably it's changing. And what we're going to do here is we're going to figure out exactly how it was changing. At what rate was the population changing at the start of the year 2000? Because the rate at the start of the year 2000 is probably different from the rate on January 3rd of 2000, right? It's changing all the time. So we're going to really focus in at the start of 2000 and find how fast the population was growing. And we're going to do it by plugging in to that formula up above, same as the one we did before. So how about we do something like this? Let's say 2000 will be zero, I guess. Zero is going to be our starting point. And we want to pick some other number very, very close to that number. We don't want to go too far from the start of 2000. So how about 0.001, something like that? Maybe we're looking at the change in population in China from like midnight at the start of January 1st to like 1202. I don't know what 0.001 of a year is, but we're not going very far. And we're going to figure out how many people were born in that 2-minute period or something like that. So let's give it a shot. We're going to use that formula right up above. So the formula says do this. P of 0.001 subtract P of what number? 0. Divide by how much is H according to what we've made up here? 0.001. It's the difference between those two numbers. Now it's actually a little bit annoying to do the 0 first because Abby's question about the 0 and the 0 in this problem, I want to just do the 7 number as well. So what might we do if we're focusing in on the time t equals 7? Which of those blanks contains the 7? That's the last one. What should the first blank contain? Okay, so we'll just go a tiny bit away from midnight of the start of 2007. And what goes on the bottom? It's 0.001. It's the difference between those two numbers. And so you can see the numbers in the parentheses, really they could be anything, but the number on the bottom, the H, always very close to 0. Okay, so with the calculators, can you guys maybe split up the work a little bit? Some of you do the blue, some of you at the table do the red, and check in with each other. So the first thing I do with this kind of problem is define that function, so I don't have to retype it on the main screen, twice. So that function is inside of y1, and then do you guys know how to access y1 of, like the f of notation?
No.
Okay, so this is an important thing to be able to do on the calculator. So if you've got your y1 as your rule there, and then you're here on the main screen, what you do is you go to vars for variables. You hit the right arrow to scroll over to y variables. And you have 4 choices. You just want the first one. It says function. And then there's your list of all the different y's that you could have typed in. So that's y1, and it behaves just like f of x notation. It's y1 of a number. So if I wanted to plug in, say, y1 of 5, this will tell me the value of the function at x equals 5, which is the population at 2005. Okay, so I think we've got our answers here. So this, I guess I'll circle it in blue. So this top number is the rate of change of the population at the start of year 2000, and then the bottom number is the rate of change at the start of 2007. So if we wanted to write this including units, it says in millions of people per year. So these are measured in billions of people per year. And I want to make sure those make sense. I mean, I just said write your answer in millions of people per year, but what were the units of the things on the top of our fractions? What are the units of P of 7? Billions of people. That's what P of 7 is measured in. This 0.01, that was how long we waited between the two moments in time. So that's years. It's 0.001 years. So it's billions of people on top per year. So this 0.0088 is billions of people per year, but that's not a very useful number. So how many places do I move the decimal to make it millions per year? So we're going 3 between billions and millions. So that really is about 8.8 million people per year. At the start of the year 2000, China's population was growing at 8.8 million people per year. Does that mean that if we just wait until the start of 2001, we will have 8.8 million more people in China? No, this is an instantaneous rate of change. Suppose you're driving down the highway right now at this moment and you're going 60 miles an hour. Does that mean an hour from now you're going to be 60 miles away? No, only if what? Only if you kept it. If you kept it a constant 60, then sure, you'll be 60 miles away in an hour. But as soon as you take your foot off the accelerator or give it some more gas, like all bets are off. The accelerator is just saying at this moment in time, the velocity is 8.8 million people per year. At that moment in time. But if you wait 3 seconds later, it could be a slightly different number. It's just at that instant. And then the same kind of thing over here for 2007. The population was changing at about 9.3 million people per year. Any questions on that?
Maybe sort of tangentially related. Is there a way to make the calculator spit out the numbers, but to make spit out results in definition?
I think, yeah. So I think that I think we can get scientific notation somewhere. Is it in here anywhere? Yeah, right at the top there. So if I did my same calculation, so I don't ever use this setting, but I'm hoping that gives me something in scientific notation. Yeah. Good question. Okay. All right, let's go to number 5. We'll go here to Kevin.
The limit as h goes to 0 plus h depends on whatever h is called the derivative of the function f at x equals a. Note that the independent variable will usually be x, so we'll generally use x instead of b. It is denoted by f prime of a. No, we read f prime.
Okay. So that right there is the definition of the derivative. Just a little notation thing. We've been using t for time, but we're going to relax the idea that we're always going to be using t as the independent variable. We'll generally call it x. A is the number that you are focusing in on, the moment in time, say. And again, getting back to Abby's question, h going to 0 is part of that definition. We could have 7, we could have 15, a could be anything, but h is always going to 0. All right, so we are going to Blaze to summarize. Okay, so that's the definition. That is the derivative. We'll be using that word almost every class from here to the rest of the semester. And that's it. So that might be something to throw on the index card if you want to have that in front of you when you take the quiz. Okay, we'll go to Tony, finding.
Finding the derivative functions as differentiating function as a derivative. The function is called
Differentiable. That's a tough one. Thank you. Ernie. Okay, we'll go to Garrett for 6.
As we've seen, the average rate of change of the function f a plus h minus a over h is the slope of this. As h goes to 0, what does this mean?
Okay, so we've answered this question on a couple of different days. We have seen this question. I think it's that important. Secant line becomes what when you squeeze h down to 0? It becomes the tangent line. Okay, and then we'll go to 7. I think we'll go to Andy in the back. Okay, so this is another little demo that I had made up. You are looking at the function pi times x squared. What's the name of the graph? That's a parabola. And you've got the special point over here, which at the moment is at x equals 2. And it's probably too small for you to see in the back, but anyway, the axes say that's around x equals 2. And then there's a slope. The slope of this line right here is at the moment about negative 11.2. Is that a secant line or a tangent line? As a secant line. I can imagine, if I ignore the left-hand side of the graph, that the right-hand side of the graph represents China's population. As time passes, China's population is growing. And what would you say about the rate at which it's growing? Is it growing slower and slower, constant, or faster and faster? It's faster and faster. Every unit step to the right, you're going to gain more vertically than you did in the previous step. But we can be more precise than that now. That's what this derivative is supposed to tell you, is precisely at what rate is the population growing at time t equals 2 years, 2002. Okay, so this secant line, is it a good approximation for the tangent line that we're interested in? No, that's very far away. We want to take that lemming, I called it a lemming because it's just going to follow the special point. So we're going to move this guy. You can see the slope has changed. It used to be negative 11, now it's negative 6. And we can keep moving it closer and closer and closer until we land basically right on top. What kind of a line is that called? And if I got it perfect, it's a tangent line. And the slope of that tangent line in this picture is about 12.6. That represents the rate at which the function is changing at that instant. At the instant t equals 2 years, the population is growing by 12.6 people per year. Just kind of making up some units. Let's see if we can move the special point someplace over here. We're going to try to keep that other number in mind. Was it 12.6? Okay. Do you think that the slope of the tangent line here is going to be more or less than it was a moment ago?
Greater.
It's going to be more because it is steeper over here. But now we're going to say something even more specific than saying it is steeper. We can talk about how much it's steeper. We can be exact using that idea of a derivative. The slope at this moment is about 25. What was the other one? 12.6? Okay, so you can see that it has changed quite a bit. And at that one moment in time, the population is changing by 25 people per year, only for an instant. If you wait like a minute later or a second later, that number will go up a little bit. Another way to think of this tangent line, suppose that you are driving a car and this is the track. The green is the track, so you just have to stay on the road, which means follow the green. And then let's say you get to this point right here, the special point. If you decided to stop following the track, you decided to stop turning the wheel exactly the right amount so that you would stay on the green. If you were just at that one moment in time, let the wheel be straight. You wouldn't follow the green. What would you follow? You would follow that tangent line. It's another way to think about tangent line. If you are following the track and then you decide at one moment in time, you're just going to let the wheels go straight instead of continuing to turn to follow the track, then you are going to shoot off into space on the direction of the tangent line. That is your tendency at that moment, is to follow that rate of change, that straight line. Yeah, try it out. Okay, so that is that. Put this guy away. Oh, I wanted to do one negative one as well. Let's try something over here. We'll go out to, say, -7. What kind of a slope are we expecting for the tangent line there? A negative slope. So we're looking for this number right here to be some negative number. -44. It's steeper than either of the positive ones we saw before. If that's China's population, it is decreasing quite rapidly, -44 people per year. And maybe one last special point. What can you say is happening to China's population right down there at the bottom? China's population, if I hit the bottom point, has a tangent line slope of 0. What does that mean about the population? It's not changing. If China's population were to continue to do what it was doing here at the bottom, it would stay a constant. It wouldn't grow, wouldn't shrink. It would just be constant with 0 people. Yeah. Okay, let's come back to here, number 8, and we are around to Abby. Okay, so we're going to have Richard right now read the part that is not in bold, and then the class is going to join in bold, okay? With lots of enthusiasm. All right, go ahead, Richard. The derivative is slope of the tangent line. Wonderful. Thank you, guys. All right. So let's go to number 9 on the next page. Josiah. Okay, so first of all, e to the x. This is maybe the first time we've talked about the number e in this class. We will spend more time in a future class talking about e. At the moment, I'm just hoping you remember e is a number, and anybody know about 2.7. That's all we're looking for. E is a number just like pi is a number. E is around 2.7. That's all I'm looking for at this moment. E is around 2.7. And the graph of e to the x is given in this picture. Now, Josiah read it correctly. If you haven't had any experience with derivatives, then it's going to take some time to get used to the idea that you don't read f apostrophe 0 or something like that. It's f prime of 0. That's what we're saying. F prime of 0. We're going to see that prime over and over again almost every day throughout the semester. So let's get in the habit of using that symbol and reading the symbol and starting to understand what it means. Yes, Joe.
What is the symbol? Like, you can't really see it.
It's an apostrophe.
It's
Yeah, that symbol is an apostrophe. Yeah, so that's exactly what that means. And so now this is our interpreting. What does the symbol mean? This means the derivative at x equals 0. Then according to the little mantra that you guys chanted a minute ago, what is the derivative? Yeah, if you just say the tangent line, you're missing a really important word. What is the derivative? It's the slope of the tangent line. So the derivative at x equals 0, or the slope of the tangent line at x equals 0. That is what that symbol is asking for. It's the slope of the tangent line at x equals 0. Okay, so I guess what we should do is draw a tangent line. So take a straight edge if you can find one, and just ballpark the tangent line. Okay, so we draw something that looks like it's going to be the tangent line. Again, it's just supposed to barely graze the curve and then run away. And then we just have to estimate what about that line? Slope. That's what this is asking for. So by counting boxes, you are doing a rise over run, and really it means count the boxes. So roughly, what kind of slopes did we get? A few people got 1. Anybody get like 1.5 or 0.7? Like there's a wide range of acceptable answers here. 1.026. Wow, it's very precise. So let's get in the habit of writing good notation. F prime of 0 is approximately, according to our estimation of the slope, 1. And so generally, here's my philosophy on notation. The further up you guys go in terms of the sequence of classes, the more I expect of you in terms of writing things correctly. If you're in an English 101 class, maybe the grammar could be a little bit off, spelling could be a little bit off, punctuation could be a little bit off. As you take your second semester, you know, like what are the next courses called? Like English 115 or I forget the 114. The expectations are higher, right? Fewer spelling mistakes, fewer grammar mistakes, fewer punctuation mistakes. This is a language that we are learning here. It's the language of math involved in calculus, and the expectations have risen from when you took a pre-calculus class. And so even if you took a class with me, my expectations are higher. And so I'm expecting things like that, where you don't just say 1, but you say a complete sentence, a complete calculus thought. F prime of 0 equals 1, or is approximately equal to 1. Okay, so that is good. And that's all that I'm after in this problem. But if you wanted to, you could use the calculator. Well, I'll just go to the screenshot we had before. You could do something just like we did in these screenshots with the China problem. instead of this function, what function did we have? E to the x. And so you just fill in, and just keep using that same formula, the definition, and you'd get a numerical from the table or from the calculator. Okay, let's go to number 10. Oh yeah, Tony.
Making an emphasis on notation to be correct. Approximate rather than the equal is also very important, right?
I mean, in this one, not super important. If you had said, I mean, I use the word estimate. So if you said, okay, my estimate is f prime of 0 equals 1, I mean, it captured in the word estimate is that, yeah, either way is okay. Good question. All right, we are on number 10. Todd. Okay, so this is hearkening back to your days of high school geometry. You guys had lines of circles that look like that and lines of circles that look like that. You guys remember the name of the right-hand line? That was a tangent line. And the left-hand line? Yeah, I don't know if, maybe some of you guys remember that was a secant line. Garrett, on one of the earlier classes, you had asked a connection between the words secant and tangent for trigonometry as the trig functions and secant line and tangent line. And we did a tangent line one, but I didn't have a good one for the secant function. But maybe it just comes from this circle word.
Yeah.
All right, so true or false? Secant line of a circle touches a circle in exactly 2 points. That is true. We are up to Sam B. Okay, is that true or false? That's also true. Okay, we'll go to Toby for C. What do we think? One does depend on the function. So if it could be false in some cases, then it's false. But for example, could you draw a secant line in this picture down here? This is the sine curve. So for example, if I wanted to connect 2 points and say, all right, that's what kind of a line if I connect 2 points? That's a secant line. Does it hit the graph only 2 times if I extend the line forever? No, it looks like it's going to hit another time. So that's false. Secant line could hit many, many times. It's going to hit twice, but then maybe some other places that we weren't really intending, but that's okay. Yeah, at least twice would make it true. Okay, and then Bubba. True or false? It's also false for the same reason. Let's see, can we do maybe for example, a tangent line at that point? Would it be a downhill slope or uphill slope? Uphill, slightly uphill, and it's going to hit the sine graph right there, but randomly it'll hit some other place too, which is not a problem. So that is false. So I think on the first day I had said, here's a bad definition of secant line. It's a line that hits the graph twice, and tangent line, a line that hits the graph once. What's the right definition of tangent line? It's the one that we just saw. The tangent line is the one whose slope is given by that crazy formula. That's the definition of the tangent line. Doesn't matter how many times it hits the function. Okay, so let's go down here to 11, and we're at Tiffany. Okay, so what I'd like you to do is draw 3 tangent lines. So use your straight edge. We're drawing 3 tangent lines and then estimating their what? Their slopes. Okay, so let's get some estimates. I've ballparked my 3 tangent lines. So the first one, f prime of 0, that means x is 0 and draw the tangent line. So x equals 0 happens to be the point that's at the origin. So I draw my tangent line. What color is my tangent line for this one? It's green. Estimate the slope of that line, and again, there's a wide range of acceptable answers. So a few votes for 1. What'd you say? 1. Really, I'm just looking for something positive and around 1. That's all I'm looking for. So that one looks like it's about 1. 2.4. So we go to x equals 2.4. What color is my tangent line at that one? This is pink, purple, magenta. Okay. So 2.4 is that dot. Estimates for the slope of that line? Something around -1, really just looking for something negative and not too big. Finally, -pi/2. All right, we're going to review the trig functions on one day coming up down the road. But -pi/2 is a special point on sine graph. So I'm hoping you know where that thing is. -pi/2 is actually the bottom point. So it's this first bottom point here with the blue line. So I've got my blue tangent line, and if we know -pi/2 is that bottom point, then actually this one is not an estimate. What is the slope of the tangent line at that bottom point? Yeah, it's exactly 0 without doing any formulas. If we understand the idea of tangent line, then at a bottom point, it's got to be horizontal. So the slope of that line is 0. So then it feels like we're saying, let's see, the smallest one is f prime of 2.4. So that's less than, what's the next one? -pi/2. And then that one is less than f prime of 0. So I'm writing it out again just to encourage you guys to become familiar with that notation. F prime of 0 is a very precise thing. It's your job to know what it means and then to be able to write it down. All right, so if we've got that, I have a quick sketchpad thing for that one too. So here's the same picture. But the nice thing is it's pretty easy in Sketchpad, or maybe more importantly for you guys, easier in Geogebra, which is that free software we mentioned, to just draw the tangent line and have it not just be a tangent line at a particular point, but have it be a tangent line at a point that I can move. So the first point that we had was 0. And so the x coordinate you see is 0. And that looks like, well, I mean, that is the tangent line. By the way, I built this thing. And what's the slope? According to this, it's 1. So f prime of 0 is 1, which was the estimate that I think a lot of us had come up with. The next x value that I asked about was what number? 2.4. All right, so we're going to zip over to 2.4. So 2.4, according to, so close. There we go. 2.4. And the slope of this tangent line is -0.74. We had estimated -1. It's not bad. It turns out it's not quite -1. It's about -0.74. We'll have ways to actually get that number without fancy software soon enough. But anyway, something negative and not too big is all we were looking for. And then the last one was -pi/2. Now, unfortunately, this guy is not going to ever say -pi/2, but let's see, pi is about 3.14. So half of that, 1.57 is all we're looking for. So I'm going to try -1.57. Okay, something like that. You can see I didn't hit it perfectly. 1.57 isn't perfect because the slope should be what? Should be 0. The slope of this particular line is a 0.01. You can see it's starting to rise a little bit and hit the curve again to the right. But anyway, this picture I think is the key for today, is that the derivative is the slope of the tangent line. And by drawing tangent lines and estimating slopes, you can estimate derivatives. Questions on any of that? Okay, let's go back to here. We'll go to number 12. Where's our reader now? Is it Lindsay? All right, so I'm just going to put it out there as a warning that most of you are going to hate this question. I feel like that kind of lessens the blow if I warn you ahead of time that this is going to suck. It's just like advanced warning. All right, so first our definition. So we'll just write it up here for practice. So f prime of a equals, see if you guys can fill in from memory any parts of the definition. It was a long definition. We said it was the most important definition of the year. It's got lots of symbols, lots of pieces in it. I'll give you a hint. It starts with a limit. That's the first part. What's that? You like the prime. Yeah. Good shortcut, yeah. Okay, so we've got our definition up here. Now look, this is not a class about just brute memorizing. I'm hoping that we actually get to a place where that definition makes sense. I mean, like, it's fine to have it written on your index card, and when we take the test, you'll have an even bigger index card you can write stuff on. So you never have to memorize that formula. But I'm hoping that the stuff that we do, you know, kind of makes it seem that formula right there is reasonable, that we're just moving a little bit from some fixed point and finding a slope of a secant line and then trying to turn it into a tangent line. Like every piece up there, I'm hoping, has some connection to a picture for you. Okay, so first thing we need to do is figure out what A is. So what is the value of A in this problem? It's 2, because it says f prime of 2, and A is the x value. So A is equal to 2. So I'm not going to write that limit thing in the beginning. I'm just going to write the difference quotient part. So we need to do f of something minus f of something over something. I filled in the blank. So the h is on the bottom, always. Instead of a plus h, what do we have? 2 plus h. Instead of f of a, f of 2. Okay, next part. Let's go ahead and do the f of 2. That's the easy part. How much is f of 2? 1/4. Okay, the h is sitting on the bottom, no problem. And then we have f of 2 plus h. It's easy once you get used to it, but it's also really easy to make a mistake. I guarantee that you know, some of you guys are going to be tempted to do something like this: 1 over 2 squared plus h. You know, like just plug the 2 in and then stick on an h at the end. That's not right. So we need to do f of 2 plus h. So it should be 1 over x squared. Instead of x, what are we plugging in? 2 plus h. And that guy is squared. Are there questions on that? The reason I keep harping on that is because if on a quiz or a test I ask you to do out this long limit definition of the derivative, and you make a mistake right there by just sticking a plus h at the end, like everything else is going to be wrong. In fact, everything else I think will be pretty trivial. You know, you won't get the right answer, but you won't even have an opportunity to show me you understand the basic idea of the algebra that has to come. And that's going to be problematic in terms of losing points. So I'm hoping we don't make that mistake because that is so early in this long problem. Okay, it might be tempting to FOIL. I'm going to hold off on foiling for the time being. I am going to say we need to combine upstairs. I need to make one fraction. Ultimately, the goal is what Garrett had said, is to cancel the h in the bottom. Definitely don't cancel the h that you see with the h in the parentheses. That h in the parentheses is very much sheltered right now, so that doesn't cancel. But at some point, after we filled up all of this space, we'll be able to cancel that h in the bottom. But we need to combine those two fractions. So what do you need to find when you're subtracting two fractions? The lowest common denominator. That is what we need. All right, this is kind of the worst case lowest common denominator because we need both denominators, everything in both denominators. So let's see if we can do this in one step. So this is equal to, so I'll go ahead and just copy the h on the bottom. That's sitting there. And then I'm going to make one big fraction up here. And I claim that the denominator is both of them together. There's a 4, there's a 2 plus h squared. That is the new LCD, least common denominator. And I don't know, you guys have in your mind this kind of idea of like crisscrossing, like that 4 needs to go up there and that 2 plus h squared needs to go there? Some of us with me? So, I mean, we need the right denominator, and let's see. So here is the correct denominator. What is this thing missing? Oh, this is a times because we're finding the lowest common denominator. Like if you had 1/3 plus 1/4, what's the LCD? It's 12, right? You multiply those. So there will be a minus up on top. So maybe if I put that, well, like there's still a minus. Okay, so one more time right here. This is the common denominator we seek. What is that term missing? Is the 4. So if I need a 4, then I'm going to put a 4 there, but I better multiply the top by 4 as well. Yes? So that guy just becomes 4. And then we'll try again. Here's the common denominator. What is this denominator missing? 2 plus h squared. So we need to put right up here 2 plus h squared. So that guy times 1 is just 2 plus h squared. So that's the kind of crisscrossing thing I was talking about. I think I said this the other day. The general concepts of calculus are really not all that difficult. It's the algebra that gets most people. Most people struggle with calculus, I think, is really a struggle with the algebra. All right, so let's keep going here. This equals, all right, so I am going to FOIL upstairs. We have a 2 plus h squared, so FOIL that out. What have I not copied yet? The h in the bottom. Okay, I get tired of writing fractions within fractions. So the ultimate question is, this h right here on the bottom, it either belongs up here or down here. Those are the only choices. So is that h in the bottom really on top or really on the bottom? 2 votes for top. So if you're not sure where it belongs, then you have to do something to physically move it. It's not, you don't need to memorize a million rules. If I don't like that h there, how about I multiply it by 1 over h? That will get rid of it. Yes? So if I multiply there by 1 over h, I better multiply up here by 1 over h. Yes? Do the same thing on top and bottom. So I now ask you, does that h really go on top or on the bottom? It's on the bottom. It's 1 over h. That h is sitting right here next to its friends in the bottom. Good. And if you are into memorizing stuff, I guess the good news is here, if you're doing this limit definition of the derivative, the h always goes on the bottom. I mean, it's always going to be on the bottom there, and it will always end up on the bottom, whatever you're doing. All right, let's see if we can get rid of all those crazy things messing up our picture. Okay, so I'm going to stick that h right there on the bottom. That's this one. Okay, another opportunity to make a mistake is to forget these parentheses here. If you don't have those parentheses, things are not going to be right. And then something nice is about to happen. Earlier today, I said everything without an h needs to go away so that we can factor h out. Do you guys see what cancels in this at this moment? It's those 4s. All the number things, everything without an h has to cancel. So this equals, don't forget that negative sign, negative 4h minus h squared over the whole long denominator. As a general rule of thumb, you never need to FOIL on the bottom, but you are always going to FOIL on the top. Okay, what can we pull out upstairs? Factor out the h. That's been the goal from the beginning. I want to get rid of the h on the bottom. I'll be able to as soon as I factor out h on top. What's left upstairs? I get 4 minus h. We'll copy the whole denominator. What do we get to do? Cross off the h. We just won the game. That's the goal right there. As soon as you cancel that h, everything else is easy. but it's a long game you have to get through before you win. I don't think that any individual step that we just did, all this algebra, was hard, but just the like accumulation of all the different steps is what makes these problems difficult. It's just so many chances to make a mistake, and if you don't have a clear sense of the direction you are headed, then you might just kind of flounder off, you know, in one tangent or another. So this is it. I'll go ahead and write it one last time because we canceled the h's. So we have -4 minus h over 4, 2 plus h squared. Yeah, that h is not a problem. Okay, so let's talk about why. Remember, in the beginning, we still need a limit. We haven't done the limit yet, but that's going to be easy. But what does h go to every time in this limit? 0. So if you try plugging h equals 0 into this guy, what do you get on the bottom? You get 0. That's a problem. We're about to plug h in for this guy. Are we going to get a 0 on the bottom? No. So that h is no problem. Okay. So let's go ahead and write it with the limit in the front. So let's go use good notation, actually. F prime of what was the magic number we plugged in? It was 2. That was what we were after in the beginning. It's the limit as h goes to 0 of this whole thing. Yes, that's exactly right. The goal the whole time has been plug in h equals 0. We couldn't do it until we just canceled that h. I did, but then on the next page I said just go ahead and plug it in. It's well, look, we've got like the politicians, the presidential candidates flip-flopping all right. Like I'm allowed to. This is just a very small issue that I'm flip-flopping on. Okay, so we plug in h equals 0, -4. I mean, you don't need to write the zeros, but I will just to really show that we are plugging in h equals 0. 2 plus 0 squared. Upstairs, what do we get? -4 over 4 times 2 squared, 16. F prime of 2 is -1/4. Whew. I'm winded. I need to sit down. Thoughts on that one? Mm-hmm. All right. Mm-hmm. Yes. Yeah. So that's a really good question Abby is asking. So let's actually take a look at it on the calculator. There we are. Yeah, what we did was the exact calculation. If we had wanted to, we could have just estimated the way that we've been doing for a while. So how about we just pick, instead of 2 plus h, we're just going to pick some number near 2, like 2.001. So if we do this on the calculator, let's see. So we're doing 2.001 inside there for x. So we go 1 divided by 2.001 squared. And then what are we subtracting? 1 divided by 2 squared, right? We're doing, I mean, it's the same thing. It's f of 2.001 minus f of 2. So we get that. And then we divide by what number? It's the h, which is the 0.001. Now before we hit enter, remember the right answer, the exact answer is -1/4, -0.25. So if we divide there, we get -0.2498. It's kind of a lot of work for the exact answer relative to how close you can get very, very easily. But it's a nice connection Abby has just made for us. Yeah. Yeah, if you get something that's totally different, then there's a mistake somewhere.
It would be nice to double check our work, except we're not going to have calculators on our test.
That's true. True. So let me show you real quick. Again, this is GeoGebra, and I think that we can do this fast. So let's make it real big. Okay, so the function that we were playing with was what? 1 divided by x squared. So there's the graph of that function. Again, this is free software. Just go to geogebra.org or Google GeoGebra, and like literally you just type it in the bottom there, and it graphs the function for you. And then, so I actually have not tested this out before. I don't know if this is going to work, but what number did we want? F prime of 2. That's it. That's it. It's pretty quick. Yeah. And again, like I want you to have a geometrical thing happening here. There's a tangent line that should be drawn. Where should I think about drawing the tangent line for this f prime of 2? Is it x equals 2? So you can see, I'll put the grid up here. So at x equals 2, that's this point. All right, let's go ahead and plot that point. It's 2 comma, it was a quarter, right? Okay, so there's the point. And can you imagine in your mind a tangent line at that point? Is it sloping uphill or downhill? Downhill, so the slope should be what kind of a number? Should be a negative. Would you say it's very steep downhill or relatively flat downhill? It's relatively flat, so something not too big. Negative, but not too big. Okay, this is seeming pretty reasonable to me. I think that actually there's a button up here. If you go into this, if you hit that arrow, one of the options is tangents. Well, normally there's directions up here. I'm not sure why they don't appear, but I'll tell you that the idea with the tangent tool is you hit the point. So I'm going to click on that point, and then I'm going to click the function, and then it's going to draw the tangent line. And you can even see if we move this a little bit, that right there is the equation of the tangent line. Where do you see in there the derivative? It's the slope. You guys know that's a y equals mx plus b. The slope is negative 0.25. Of course it is. That's the derivative at x equals 2. Okay, so homework is in the usual place, and we'll see you guys on Friday. So again, show up 10 minutes early if you want to start the quiz early.